stage 4 of this fight, and the opponent challenged the reporter for problem. Number 8.
We reject the charge.
Okay, reject. Number 8, rejected. Okay, so opponent challenge again. Now, 18th release. Sorry, 13th release.
Uh, 13 charge man.
Okay, so
We reject the charge.
okay, so reporter rejects number 13. Okay, so 11, problem 11 is released. And 6, 11 and 6 is released. Number 10.
We reject the charge. Reject.
Reject. Number 10 rejected. So so problem number 11.
We accept the charge.
Okay, problem number 11. So the reporter has 5 minutes to prepare. And each team member for the reporter, opponent, and reviewer write your name on the board. And reviewer, please write your name on the board. Okay, reporter takes the floor.
Honorable jury and fellow participants, I'm the reporter from TYPT D121. And today I'm going to report our example from his group. Here is the problem statement. A simple water pump can be made using a straw shaped through a triangle with a open and reversible. When such a triangle is partially immersed in water with one of its verticals and rotated around its vertical axis, water may flow out through the straw. The rest can follow geometry and other relevant parameters of faster pumping speed. And our main focus is how this device works and how does the pumping speed depend on a relevant parameter that lies to the length of the input. And this is our concept. We will talk about the animation first, and then the theory, experimentation, and finally the conclusion. First is the observation part. This is the observation video. You can see from the video. When the straw started rotating, it was without the water and the video. It comes to the qualitative explanation. When the straw starts rotating, the pressure inside the straw will be less than the water outside the straw. So the water will be sucked into the straw, and because of the centrifugal force, the water will be pushing outward and finally spread out. And also, here we are going to define the pumping speed as this, the amount of water spread out the linear time. And then comes to the theory part. This is the force analysis diagram. You can see in the diagram. We thought that there are three main forces that work on this system: the centrifugal force, the gravity force, and the force caused by the variation of the pressure. And then we can guess the formula that describes the three force balance on the blue axis of the picture. And here's the detailed explanation of the centrifugal force. This is the formula of the centrifugal force. In this system, we interpret the centrifugal force of the water as flow in each position. And we can get the total centrifugal force at C. And the total centrifugal force work on the blue axis will be like this formula. And next force is the force caused by the variation of the pressure. To explain this force, we insert the Bernoulli's equation. Because of the pressure difference, and there are two forces that's caused by pressure difference, both the dynamic pressures and the static pressure. And the red one is the dynamic pressure, the blue one is the static pressure. And also in the dynamic pressure, this refers to the velocity of water outcoming the straw, and it refers to the velocity of water in particles. And also the median can be described as the distance from the rotation with the rotation axis and I square angular line. And after calculating, we can insert three forces in the formula, and we can get the force. And after solving the force, we can get this formula that describes the flow velocity, also known as the pumping speed. The next is the experimentation part. This is our experiment setup. First, we use the straw to make different kinds of pump, and then we connect the rotating axis of the straw to the motor, and use the aluminum structure to ensure it is stable and is horizontal to the front. Also, we make based on the pattern of the container to ensure that the straw is rotated vertically and stably. Also, we put our four devices on the electronic scale in order to calculate the amount of water spread out per unit time, very kind of mirror of minute. And we connect the motor to the power supply and control the current and the voltage of the power supply to ensure that the angular velocity of the pumping screw is the same. And also we do tracker to check every experimentation to make sure that the angular velocity is the same in every experimentation. This is the first variable, the angle of the screw. The independent variable is the angle of the screw. And the dependent variable is the amount of water spread out per unit time. And the control variable is the diameter of the screw, the length of the screw, the immersion depth of the screw, and the filter. This is the experiment result. This is the experiment result, the angle of the screw. You can see from the picture that the blue line is the theoretical result, and the green line and the orange line is the experiment result. We see that the deviation between the two results is because of the water resistance and some friction. The tendencies of the robotic both will decrease if the angle of the screw becomes bigger. The next variable is the length of the screw. The independent variable is the length of the screw, and the dependent variable is the amount of water spread out per unit time. And the control variable is the angle of the screw, the diameter of the screw, the immersion depth of the screw, and the filter. This is our experiment result. The blue line is the theoretical result, and the orange line is the experimental result. We can see from the result that the tendency of both results, when the length of the screw increase, the flow velocity will decrease slightly. And finally, is the conclusion. What is the theory? In the theory, we use the centrifugal force, the gravity force, and the force as the variation of pressure to balance. And then we can get the formula after practice. And for the experiment result, the angle of the screw decrease, the amount of water spread out at unit time will decrease, and the pumping speed will decrease, and the pumping speed will increase. And if the length of the screw increases, the amount of water spread out at unit time will decrease, and the pumping speed will decrease. Right?
Okay, so the opponent has questions.
You say that what is the angle you make?
This is the rotating axis, and this is the screw. The angle is the rotating axis.
Okay. So
Okay, no verbal communication. Hello? No verbal communication. You can pass on notes. Okay, so then the opponent has 3 minutes to prepare. Okay, the opponent takes the floor, maximum 4 minutes.
Okay, so our problem will focus on what kind of angle will be the best in the experiment, and other settings of the experiment series will affect the pumping speed. So the pros and cons. The pros is they have enough theory to talk about this problem. And the con is the main reason on why the experiment data is not agree with theory data might be because they didn't make other angles to check their point of theory is correct. Okay. And the phenomena they observe that is how the water is being pumped. And their experiment is by changing the angle and see what will happen. And their theory is suggestion is for further they can make more experiments to make sure their theory is correct and maybe try to find maybe other things like how it will affect. Okay, thank you.
Okay, so continue the discussion.
First is, can you turn to the previous page? Yeah. And why is force caused by the variation of pressure is something?
Because pressure is in the slow is lower.
So it's lower.
Because the slow
So
in this.
so it's because the pressure here is lower.
No.
Oh, here is lower. Why the pressure here is lower?
Because this system is not complicated. It will when the system is started, pressure inside the pressure inside the rock will become lower. And stabilization pressure will and its direction will set with the flow direction.
You mean pressure is like air pressure or what?
Oh, take off your mask, please. Your mask, please.
Stagnation pressure. The pressure is as the relation from this to this are different.
Okay, let's move on. So you only consider these three forces, right? But
Every time we didn't consider the force given by the supporting of the because we only consider in the this
okay, but maybe because the water is moving and there might be wait a second. Because the water is moving in the stroke and there might be friction.
Because we didn't consider fusion in this, so as you see the fusion is the calculation in our experience.
So you think it's because the theory didn't consider the friction, so the experiment result and theory didn't match.
A part of this or other resistance in the actual fact. That's it.
So you say what will happen if you increase the length of the stroke?
The performance speed will slightly decrease.
Okay, so the water will not turn. The So this is your speed when water just came out from the straw, like this. So do you think it will be same during all the time, or it might change? Like when it starts to rotate, the speed is increasing and it's not like just a constant.
Since it's stable.
Why you think it's stable? Do you use pressure or other way to prove it's stable, or you just guess it is stable?
So we use the pressure to check the amount of water spread out the pipe. So we can see on the graph that is the set solution type. There is no water also the same. Also the rotation speed will be stable of the speed.
When the straw is rotating and pumping the water, the volume of the water in the volume of the water is in decrease, like let me go in. Like at the beginning, the water might like
You need the water in the
yes, the water height is not a constant. It will be
so
lower during.
we only calculate the experiment result in the first example because we observe that the pumping speed is the same in the first experiment.
So did you
Because the our container is the cross-sectional area of the container, so it won't decrease that fast.
did you why you think the water didn't increase too much?
Because we use a container that has a big cross-sectional area. So we only use the first data.
Okay, time's up. The opponents have 1 minute to summarize the discussion.
Okay. So first, they didn't make more experiments which change variables to check where will be different on each different variable of experiment. They can try to make experiments such as how will the data change on increasing length of flow, or what will the data change on different angular velocity. They have enough theory to support their point on the problem, but they have no enough experiment to support their point. And their theory had some more things to be considered.
Time's up. So the reviewer asks questions.
Yes, I have some questions for opponent and reporter. And I want to ask the opponent that what is the definition of the pumping speed?
I think the pumping speed the reporter mean is the water being.
And you agree with the speed?
No, I think the pumping speed is the volume that be pumped over time.
Okay, and I want to ask both of you that do you think the water flows next to the straw will affect the pumping speed? Yes. Give me yes or no. Immerse. Yes, and it will affect the experiment results. Okay, and
I think it will affect, but the effect is little and could be ignored.
okay, and I want to ask that do you think the water can still pumping out of water when the water level is lower than the straw? Give me yes, no. It's not. No.
I think no, because the air might go in and the water might not.
Okay, and I have some discussion about the total that can you try to pay the burning response? And I want to ask that because of I know that burning response is using in ideal situations, and one of the ideal is even can't rotate. And in this experiment, I think the straw is rotating. So do you think when the straw in here is
water in straw is rotation?
yes, and burning response is the ideal situation. So do you think it can use in this experiment? Yes. And okay, I have some problems with this formula. And you can see there has a V in the formula. And I think that V is about the water flow, the speed of the water flow. And you use the omega and R and omega. And I think it's not the equal. And do you want to explain this? Okay, and can you touch your data? And I will ask that why the data and the theory didn't fit.
Okay, time's up. So the reviewer has 2 minutes to clear for your presentation.
straw and amount of the water poured out another time. And in her data analysis, the angular velocity in different parameters. Yes, and I think that process is connect with the phenomenon and use a simple model to explain the phenomenon. And do a different experiment to observe the results and correctly organize the result of each parameter. And I think the cause is a wrong force analysis and didn't consider a correct force in here. And I think it's because in the force analysis they use the zero force and it's image, so it means the observed is in the straw. And I think you need to use a correct force to fit the force analysis. And lack of the viscosity and predictor slope only can use in the ideal situation. And in the experiment and setup, and it might have an error in during the experiment process, and just like a lack of the investigate of the different parameters, and can explain some problem in the experiment results, just like a theoretical lies and didn't fit with the experiment results, and didn't have error bar and lack of error analysis. And in the next part, I want to overview of the opponent is with the short question and speech. They discuss about the definition of the angle, of the straw, and when the discussion type has the best angle of the straw to observe the result and cross analysis. And here, cons I think is indicate the unclear explanation in the report presentation, just like angle of the straw, and has a great question about the theoretical model. And in her cons, I think it didn't discussion about theory and data. And I think the data and theory didn't match. And I think the reporter need to more experience and data management, and didn't talk about the data analysis and didn't understand the reporter's answer well. And in the discussion time is also data management. And in the discussion time, the question is opponent says that do you consider the water friction in the straw? And the reporter says no, we didn't consider it. And I think it's a reason that why reporters the experiment and the data didn't fit. And I think friction in here is very important because of I think if we use the different material of the straw, it will affect the pumping speed. So the friction in here is the most effect. And the next problem is we ask do you think the water flow next to the straw will affect the pumping speed? And we think it's yes. And it meant that the floating speed decrease or help the water flow down. And the reporter and the opponent also said yes. And the next question is, do you think the water can still be pumping out the water when the water level is lower than the straw? And we think it's yes, and the reporter and the opponent says no. And the reason has, I think the secondary flow is part of the water flow systems, and then you consider and the voltage and the capillary action, and they need to more investigate of the rotating speed and which parameter of change it. And
Okay, time's up. So reporter can put in remarks. questions?
I have a question for the reporter. So how do you control the angular velocity?
We control how we connect the motor to the power supply and control the voltage and current.
So you use the motor,
Motor, yes.
it's stable,
Yes, we do.
so you provide a constant angular velocity. Constant angular velocity.
Yes.
Being stable,
In a
keep it constant.
first 3 seconds.
Huh?
In a first 3 seconds.
In the first 3 seconds. So you.
We use the shaker to the set.
So that would be great. Then I will ask you 3 questions. You have the triangle source, right? And you use one of the vertices immerse in the water, and then you rotate your triangle, right? So there are two points that would have the water pumping out. So what about the pumping rate? Is that equal for the 2 vertices, or they are not equal? So
It's equal.
And I think it depends on the triangle will it will horizontal of it. And if it trace on the side, this side will getting more water to set. So it depends on horizontal that we make the triangle rotate.
I think if the length of these 2 sides is the same, then it will be the same. But if it is not the same, then the rate will not be the same.
pumping rate will be not the same. Okay. So if one vertex is lower, the other is higher. So which one can cause the
I think the length, if the length is shorter, then the more water is being pumped.
lower one? And how about you? If the triangle is tilted a bit.
Or if it tilt like this, and I think this side will getting more water than come out.
And then you?
I think we express the longer, if it outside the water longer, it will spread it will be small, express more.
Okay.
Any other questions? Okay, I just like to point out there's nothing error in your equation. Can you go to page number 11, your presentation? So the last equation, if you check the dimension, it's not consistent. Can you tell which one is not consistent with the other? The dimension, the unit in each term. The last equation, the v equal to square root of. Now check the unit. Yeah, there's one term is not right. So any one of you can find out. Which one? Okay, point 1, 2, 3, 4. Which term? Number 1, number 2, number 4? Which term is inconsistent with the other? Which one is not consistent with the other? There's one term, the unit is different from the others. Number 4, okay. And how about you? The reviewer, which term is inconsistent?
Can you say that again? Because
In the equation, the right-hand side, there's one term, the unit. Okay, no verbal communications. There's one term, the unit is different from the others, the dimension.
usually use 2.
Number 2, and which one is it?
Sorry.
You mean that fourth thing?
Yeah.
Unit
In the square root, there's a 4 term, and that's 1 term, the unit.
I think the second one is different because it is m squared over s. It's n triple over second.
Right, okay, so the last term, okay. The first term is d, the length square divided by time square. And the second is also length square divided by time square. The third term is also length square divided by time square. But the last term is length divided by time square. So that one's different. Okay. Right, so okay, so time for the okay, score for the reporter. Sorry. Okay, 4, 5, 6, 6, 6. And the score for the opponent. Okay, 3, 3, 6, 4, 5. And then the score for the reviewer, 4, 8, 6, 7, 7. Okay. So any comment from the jury to each of the team?